right, guys, here we go. 11.7, 11.8 review. We're going to be talking again about fundamental counting principle, permutations, and combinations. If you have not already done this, stop and work through this assignment. Do everything you can do on your own. See what you know. Because we do not have the groups to bounce things off of anymore. This is all on you. You're going to be having to work through these things on your own, and I want to see how you're doing before you get to the exam next week or the week after if we put that off. So I want you to go ahead and work through all these if you haven't. I'm going to go ahead and start working through them now, so you need to pause the video if you haven't already completed this. You need to go through and see what you got right and what you got wrong and make sure you understand. The difference between a permutation and a combination. First of all, both of these are dealing with one set. That's not a difference. The difference is whether or not order matters. With a permutation, order matters. With a combination, order does not matter. Think about permutation as selecting officers, as an example. With a combination, I'm just picking a group or a committee. Simplify without your calculator. We just did a bunch of these simplification problems. This would look like 700 times 699 factorial over 699 factorial. That cancels and leaves me with 700. 8 combinations, choose 0. I would show how to simplify by saying, all right, I've got 8 factorial over 8 minus 0 is 8 times 0 factorial. We know 0 factorial is 1, and that is 8 factorial over 8 factorial. That leaves me just with 1. That same logic is going to hold for 4 pick 0. There's only one way to do that as well. Okay, this kind of hits the order of operations. I've got 6 factorial over 4 factorial because I need to do that 6 minus 2 first. So to show how to simplify, I would stop at 4 factorial, show that that cancels out, and I'm left with 6 times 5, which is 30. All right, for each of these situations, it says to decide if it involves permutations or combinations, explain your answer, do not solve. So I'm not asking for a number here, just asking you to decide if we're talking about permutations or combinations. A record club offers a choice of 7 records from a list of 45. How many ways can you make a selection? That's just a combination of records. You're getting a group of 7. How many different 4-card hands can be dealt from a 52-card hand? Well, if I get 4 cards, it doesn't matter if I get the 4, the king, the jack, the ace, or the ace, the king, the jack, the 4. It doesn't matter which order they're dealt to me, I'm getting the same hand. So that's a combination because it's a group of 4 cards. If I were going to calculate these, A would look like 45, C 7. B would look like 52, choose 4. C, how many different ways can a director select from 20 male actors to cast the roles of Mark, Roger, Angel, Collins in the musical Rent? Well, if you have ever acted, you know that roles are not the same. Mark may have lines in every scene, and Angel only walks in scene 3 and gets to say 2 words. All roles are not created equal, which means order is going to matter. It matters if you're picked for Mark, for Roger, for Angel, or for Collins. And since order matters, that is a permutation. And I keep wanting to write an A there because I'm talking while I write. Order matters. If I were asked to calculate, I've got 20 actors, and from them, I'm going to pick 1, 2, 3, 4 to play those roles. D, how many different ways can a director select 4 actors from a group of 20 to attend a workshop? Now we're just going to a workshop. I either get to go or I don't. That's a combination because I'm looking for a group of 4. E, how many different user IDs can be formed from those 4 letters if no repetitions are allowed? Well, user ID, does order matter? Absolutely. If I'm trying to log on to something, I have to get things in the right order. Assuming I have 4 spots to fill, I've got 1, 2, 3, 4 letters, and I'm going to pick all 4 of them. But order matters, so it's a permutation. All right, let's look at that next page. For the rest of this, for numbers 4 through 16, you are going to label it as permutation, combination, and that should say fundamental counting principle. If I uploaded that, it says neither, somebody let me know. I think that I got them corrected for the most part. Let me know. So you're going to label it as permutation, combination, or fundamental counting principle. Remember, if it only has one group of things to choose from, one set, it's a permutation or combination, and then I need to look to see if order matters. If there's more than one set, it's fundamental counting principle. Number 4 is a permutation because I've only got one set of bells. Order matters because it's a sequence problem. In number 5, I've got a permutation with duplicates because I'm rearranging those letters. And I have letters that repeat. My M's repeat, my O's repeat. There are 10 letters total. There are 2 M's and there are 2 O's. Number 6. Number 6 is a permutation. I can do number 6 as a permutation problem or as a factorial. I've got 11 performers, but one of them is being difficult and wants to be third. I don't know what I said. I've got 7 performers. One of them has to be third. So how many people am I actually lining up? Well, if one of them has already placed herself, let's see, I've got 1, 2, 3, 4, 5, 6, 7. Sue insists on being third. How many people am I actually arranging? Well, I'm arranging 6 people. So it's either 6, pick all 6, or I could do it like a factorial problem. I'm going to get the same result either way. Lotto. I'm picking 6 numbers correctly from a selection of 55 numbers. The order does not matter. So I've got one set, order doesn't matter. That's a combination. Number 8, there are 10 names on a ballot. I'm picking a committee. So I've got one set of names. I'm picking a committee. If it's a committee, order doesn't matter. So that makes combination. Number 9, I've got a restaurant. At a restaurant, I'm ordering a 3-course meal. So I've got salads, main courses, and desserts. That's more than one set. Anytime I'm looking at more than one set, I'm looking at the fundamental counting principle. So I'm going to pick a salad, I'm going to pick a main course, and I'm going to pick a dessert. Salad, main, dessert. 4 different salads, 5 different main courses, 4 different desserts. Make sure you don't multiply that 3 in there anywhere. That just tells you how many different sets you're choosing from. It's not a number that you need to calculate with. Number 10. You're taking a multiple choice test. Each test has 7 questions. Each question has 5 answer blanks. Well, I've got 5 different options on each of those 7 questions. So I've got 7 sets of answers. Since I've got multiple sets, this is a fundamental counting principle. 7 questions. Each question has 5 options. So that works out to be 5 to the 7th power. How many different 4-letter secret codes can be formed if the first letter must be S or a T and the last letter is a vowel? I haven't told you you can't repeat. I'm definitely looking at 4 different sets of letters because my first option is S or T. It's limited. Then I've got 2 options, and then my last set of options is a vowel. Well, that's 4 different sets I'm looking at. So it's fundamental counting principle. I'm just multiplying together. S or T, that's just 2 choices there. The middle 2 entries in the secret code can be any letter, so 26, 26. And then we're going to say we have 5 vowels that are always vowels. And how many distinct ways can a 9-digit number be made using 4 5s and 5 4s? That's a little bit confusing on the wording, but what I'm looking at is a permutation with duplicates. I've got 9-digit number, so that's a total of 9 that I'm arranging. I've got 4 of these, and I've got 5 of those. So that's the repetitions I'm dividing out. However you want to calculate that using your calculator, probably, but you could simplify first to practice. You should get down to 126 different 9-digit numbers. Number 13, contest where 8 contestants are entered. How many ways can the first 5 places, so first place, second place, third place, fourth place, fifth place, be awarded? If I'm doing places, order matters, so it's a permutation. I've got 8 contestants, and I'm picking 5 of them to be winners. Number 14, I want to arrange 8 of my books on the shelf, and order matters to me. If I've got 1 set of books and order matters, I'm talking about a permutation. So I've got 8 books, and I'm going to put them all on the shelf. Number 15, license plates. License plates in a particular state display 2 numbers, 3 letters, 2 more numbers. Assumed numbers can be repeated, but letters cannot. The first number can't be 0. How many different license plates? Okay, so 2 numbers, 3 letters, 2 numbers. So that's 2, 5, 7 different blanks to fill. And I've got different sets of items to put in those blanks. And when I've got different sets, it's fundamental counting principle. Well, there are 10 digits total. The first number can't be 0, so it can only be 9 different things. It can't be 0, so it could be 1 through 9. The second number, numbers can be repeated, so there's 10 options for that second number. Then there's 3 letters, and letters can't be repeated. So I've got 26 letters to choose from, but then I've picked one, so there's only 25 left. And then I pick another one, and there's only 24 left. The last 2 slots are numbers, and we said numbers can be repeated. When I multiply all that together, I get 140,400,000. And then our last question, how many 5-card hands can be dealt from a deck that has only hearts? Only hearts. 5-card hands, I've got 1 set of hearts, so I've only got 1 set, means it only has to be permutation or combination. A 5-card hand, order doesn't matter. It doesn't matter which card gets dealt to me first. I'm still holding it in my hand. If it's 1 set and order doesn't matter, it's a combination. How many hearts are there in a deck? Well, there's 13. And I'm choosing a hand of 5 cards. All right. That is it for our review for 11-7, 11-8. Make sure you're doing all your My Math Lab homework as well.